So we just finished learning about the kinetic theory of gases. Now it's time for us to take a set of problems, the first one of which is in front of you right now. So in the first problem you have three closed vessels A, B, C which are at the same temperature. The first vessel contains only oxygen, the B only contains nitrogen, and C is a mixture of equal quantities of oxygen and nitrogen gases. If the average speed of oxygen molecules in vessel A is V1 and that of N2 in vessel B is V2, then the average speed of oxygen molecules in vessel C is what? Prasoon is going to help us with the problem now.
So on first look, this seems to be a rather complicated question because we are given, say, a vessel A which contains only one type of gas, a vessel B which contains only another type of gas, and a vessel C in which there is a complete mixture of them. So for the mixture, like we cannot come across in the first side we might not come across anything on how to make the effective, or like what would be the effect on mixing the two gases.
Right.
But let's go to the basics, and we had the formula for V average as root over 8 RT by pi m naught.
Correct.
Okay, so this is an 8. So by this we know that for a particular gas, if we have one particular gas and we keep it in a vessel, its m naught would be the same, it won't change.
Correct.
And suppose we added another gas and the temperature remains the same. So for that particular gas the m naught is different, but for both of them the value of m naught or any other parameter in this equation does not change.
Right.
So basically because of that the average velocity would remain the same for oxygen as it was for the first vessel. So basically when we mix two or more of them and the temperature remains the same, then that won't be an issue because m naught is the same, and by the formula we can just give it to be V1 as the vessel A contained oxygen only.
Okay, so we'll move on to the next question now. Let's take a look at the second question now, in which we have two thermally insulated vessels 1 and 2 that are filled with air at temperatures T1 and T2, volumes V1 and V2, pressures P1 and P2 respectively. If the valve joining the vessels is open, temperature at the equilibrium will be what? Prasoon is going to take us through the problem.
So let's just write down what all the information we have.
Right.
So we have a valve, the first valve which is connected to another valve. Basically the vessels, vessel 1, this is vessel 2, this is connected through a valve.
Right.
So this has temperature T1, it has number of moles N1, let's say it has volume V1 and the pressure P1.
Right.
And for the second vessel we have T2, N2, V2 and P2.
Correct.
So what's given here is that they are thermally insulated. So we have to use this fact to somehow get our temperature. So let's say in our final when they are connected, then we can just assume it to be a vessel of volume V1 plus V2.
Right.
Because that would make no difference since they are connected.
Correct.
And the temperature would be T. And the number of moles would add up N1 plus N2. Okay. So let's start with this. Suppose now see the volume of the whole system. Before it was V1, this had V2, and their sum was V1 plus V2.
Correct.
And finally also we have a volume of V1 plus V2. So no work has been done. And since no heat was supplied, they are thermally insulated, nor any heat was given out. So the internal energy of both of these, which was before, would be equal to the total internal energy of this one.
Right.
So let's use this, let's write that down. So energy was F nRT by 2. F is the degree of freedom.
Correct.
Write that as internal energy. So for the first vessel we have E1 equals F is 3 by 2 N1 RT1. For the second we have E2 equal to 3 by 2 N2 R T2, and for the
Right.
final one we have 3 by 2, the total number of moles is N1 plus N2 whole into R whole into T. Because we don't know this T, let's just assume it as T.
Right.
So since no energy was lost, then the sum of these two, E1 plus E2, should be equal to this. So
Correct.
now we use this 3 by 2 N1 RT1 plus 3 by 2 N2 RT2 gives us 3 by 2 N1 plus N2 whole into RT. So 3 by
Right.
2 and R get cancelled, and finally we have our T as a function of T1 and T2
Right.
as N1 T1 plus N2 T2 divided by N1 plus N2.
Right.
Now we go back to the question. We are not given N1 and N2, but we are given the pressure, volume and temperature. So basically we can find N1 and N2 by using the ideal gas equation.
Right.
So for vessel 1 we have the general equation is PV equals nRT.
Correct.
So N1 would be P1 V1 by RT1 and N2 would be P2 V2 by RT2.
Correct.
If we substitute both of these into T, we'll have T in terms of P1 V1, P2 V2 and T1 T2, which is what we wanted. So let's just write down the final answer. As after doing the calculation, we'll get this answer as T final equals T1 T2 whole into P1 V1 plus P2 V2
Right.
divided by P1 V1 T2 plus P2 V2
T1.
T1. And the main
Right.
concept that we used here was that the energy before, the internal energy of these two before would be equal to the afterwards.
Right.
Summing that up.
Okay, so guys, and one more important lesson we learn in this question is you are given a set of variables in the main question, and since IIT-JEE is mainly objective, you will have options in certain variables. You have to make sure that you know certain amount of relations like these to convert your final solution into what is expected by you in the paper. Now we'll move on to the next question. Now it's time for us to take up question number 3, which says 1 mole of oxygen gas at 27 degrees centigrade is enclosed in a vessel which is thermally insulated. Now this vessel is moved with a constant speed v and is suddenly stopped. The process results in rise of gas temperature by 1 degree centigrade. Now it's given that m is the molecular mass of O2. You have to select the correct options here. There can be more than one correct answers. Prasoon is going to explain us how to solve the problem.
So for this question, basically there are two things we have to find out. The first is the gamma, which is Cp by Cv,
Right.
and the second is the velocity, basically what the velocity was with which it moved. So let's see, for gamma we can easily find it out because oxygen is a diatomic gas, and as we had seen in the theory part, for a diatomic gas the number of the degrees of freedom is 5.
Right.
And we have the formula for Cp by Cv equals gamma as 1 plus 2 by F.
Right.
So just substituting into it 1 plus 2 by 5, we get 7 by 5. This is equal to gamma. Now the next part is what may be confusing. So
we basically found the first part of our solution.
yes,
B is one answer.
so just take B. B is the right answer.
Right.
Now we have to find V. So the vessel is moved with a constant speed v and suddenly stopped. So when it was moved with a constant speed v, the internal energy that was there with respect to only the thermodynamic motion, it remained. It got an additional energy, additional kinetic energy with respect to its center of mass, which was given by half into m into v square.
Right.
Okay. And when it is suddenly stopped, this energy is lost, it comes to 0. And it is given here that the vessel is thermally insulated.
Right.
So basically the vessel is thermally insulated and the vessel does not change its dimensions, which is to say no work also acts on the gas which is inside.
True.
So by the law of thermodynamics, first law of thermodynamics, we have Q equals delta U plus W. Now here we know that delta U, basically delta U is changing by 1 degree. So Q might be there, the cause of it, or W might be the cause of it, but the volume does not change, so it is 0. And Q, we do not supply any heat, hence it is 0. So we might think that how does delta U is actually changing.
Right.
So that is basically because it had a particular energy, and here we apply the law of conservation of energy. So since there is no other way for this particular kinetic energy about its center of mass to go away, so that basically changes into the internal energy of the gas.
Right.
Hence using this concept, we have half mv square equals n cv delta t, because it is a constant volume process after all. So this is equal to n would be 1 into
Right.
cv into delta t is also 1.
Right.
Write that correctly, into 1, and v comes out to be 2 cv divided by m.
Correct.
Now see, we might stop here, but in the answer we do not have cv. The answer is given in terms of gamma.
Right.
Okay, so we can write down gamma in terms of cv. Let's see how. We have Cp equal to Cv into gamma,
Right.
and we have Cp minus Cv equals R.
Yeah.
So basically we have Cv plus R equals Cp, which equals Cv into gamma through this
Right.
equation. So we divide it and we find that Cv will come out to be R divided by gamma minus 1 through this equation.
Correct.
So now we substitute this answer into this equation. Let's just substitute this answer. So root over 2 into R divided by m whole into gamma minus 1
Correct.
equal to velocity. So this is the answer. So
D part.
B and D come out to be correct.
Now the fourth question says that the pressure P of n moles of a gas varies with volume V as P equals A minus B V square, where A and B are positive constants. The highest absolute temperature to which the gas can be heated is Tmax. Now your job is to find Tmax and the volume at the same temperature. Prasoon?
So let's start this. Basically, if we get a function of P as V, then we might go about solving it, and we can think of mathematical methods to solve it.
Right.
So let's see if we can make that happen. So we have here PV equals nRT.
Correct.
Okay, so let's put that in place of P. We get PV equals P, basically P is nRT by V. So instead of P we put nRT by V
Right.
equals A minus B V square. So
Right.
T comes out to be AV minus BV cube divided by NR.
Right.
So we have found T as a function of V. So now we can use the concept of maxima minima to basically find that what is the T max and at what T we can get T max.
Right.
So let's see that, how we do that. We find dt by dv, because now we have reduced T to the function of V only and nothing else.
Correct.
It comes out to be A by NR minus 3B V square by NR. So basically dt by dv is 0 at maxima or minima.
Right.
So equating it to 0, we get dt by dv equals 0. For that we get V equals to plus minus root over A by 3B.
Right.
Now we have to find whether it is a maxima or a minima. So we find the second derivative, d2t by dv2 equals minus 6 bv by nr. Now in case of a maxima, d2 the second differential, the second derivative has to be negative, because the slope at the maxima, you see this is negative and before that it's positive, so negative minus positive, the second derivative has to be negative. So if we substitute V for positive, we can get the d2t by dv2 as negative, and hence we find the volume at T max is plus
under root A by 3B.
And by the way, there was basically no logic of substituting a negative one also, because there is nothing like negative volume.
Correct.
So basically we could have done like that too. Now just the work of substituting it into the function of T max of T is left. So let's do that. Basically after doing that, if we substitute T max into the function of T,
right,
we get T max as, so we have, by substituting, we have T max equals A into V is root over A by 3B,
right,
minus B into V cube, which will be root over A by 3B whole cube.
This should be A V minus 3B V cube, right?
Yes. So let's put, no, this will be actually BV cube, because this was the first differential actually, dt by dv, in which we got 3. The T function was directly B into V cube.
Right. So guys, basically you have to take care of the silly mistakes you might tend to do sometimes.
Yes, exactly. So, and this also we have to divide this whole by NR. So basically on solving this, we'll get the answer as 2 a to the power 3 by 2 divided by 3 root 3 b NR. This is like b is inside the root.
Correct. So guys, this is the final answer for you. This is the maximum temperature, and this volume
is the volume
at the maximum temperature. We'll move on to the next question now. Let's have a look at the question number 5. It says an ideal gas is taken through the cycle A to B to C to A as shown in the figure. If the net heat supplied is 5 joules, what is the work done by the system? Prasoon.
So basically we see that the work done is integral of P dot dV from Vi to Vf. Right. Now suppose we have given a graph of P versus V, and this is a process from here to here,
right,
from Vi to Vf, and we are told to find the work done from here to here. So basically if we do this integration, we see that P dot dV, this comes out to be this area under this curve.
Right.
So for our question, if we can, because we know the states, most of them,
Yeah.
and if we can convert it to a PV graph, to the corresponding PV graph,
Mhm.
then it would be very easy to find the work done. So let's do that. We start with this. We make the axis, y-axis to be P, and we make the x-axis to be V.
Right.
Now let's demarcate all the points we know. On X we have, on Y we have 10, or the pressure. Here we have 1 and 2.
Right.
Okay. So basically we know a point A. A is 10, 1. So this would be a point A.
Correct.
Now see, in AB, what happens is that the pressure remains constant and it goes from volume 1 to 2.
Right. Guys, keep paying attention. We are transforming one graph into another. We are exchanging the x and y axis of the graph. You might be needed to do this in the JEE examination.
Yes, and see, for volume, for C part, we know that it has to be some pressure less than 10 and the volume is 2. So corresponding to that, we see the volume is 2 and some pressure less than 10. So we mark it out here. This is our C. Now we have to keep one thing in mind also, that we have to remember the order of the processes that have undergone. Like it has to be from A to B, then B to C, and then back from C to A.
Correct.
Okay. So now we can use our law of thermodynamics, which says that Q equals delta U plus W. W is the work done.
Right.
The whole Q in the process from A and back to A is 5. The delta U would be 0 because it is a cycle.
Right. It's a state function, so
Yeah. So basically the final is equal to initial and the change would be 0.
right.
Plus work done. So work done also we can decompose into 3 particular states. Work done from A to B, and then from B to C, and then from C to A.
Right.
So this.
But haven't we already gotten W here? Work done is 5, right?
Yeah, but in the question, like, we don't have to find the total work done.
Okay.
Okay, yes. So let's see that we had to find the total work done.
Right.
And we have found out to be 5 here. Okay. Now suppose someone asks us what is the work done in the process C to A.
Right, a particular path you're
Yes.
saying.
Now, like, we have got an answer, but let's see. Let's go on, explore it further. What we can get out of this graph.
Right.
So one thing is there, we do not know this particular point. That is the pressure at C. So directly we cannot use. Directly we cannot find CA.
Right.
So we use some indirect method. So that would be the work done, which is the total work done is 5, would be equal to the sum of work done in AB and in BC and in CA.
Correct.
So work done in AB would be 10 into, like, P, the pressure is constant, into delta V. So that is 10. Plus in BC the volume remains the same, so work is 0.
Yeah.
Plus we denote it by work done in CA.
Right.
Now through this we can find the work done from C to A. That comes out to be -5.
Correct. Okay guys, so we just saw how to read a graph, how to calculate the work done using the PV graph, and we also saw how to transform a graph, which is basically a VP graph, into a PV graph, how to interchange the X and Y axis in a graph. We'll move on to the next question now.